All right, I'm just going to give it a couple more minutes to see if anybody else logs on, and then we'll get started. Feel free to take a stab at answering the trivia question there on the left as you wait. Well, I guess we'll go ahead and get started. So welcome to this webinar on how to offset losses with energy efficiency projects. My name is Jen Jones. I am a technical advisor here at Penn TAP, and I will be your host this afternoon. I have just a few quick items of business to cover before we get started. If you have any technical difficulties accessing or hearing the presentation, please use the chat pad, use the raise your hand, and we will try to correct that as soon as possible for you. This presentation should last about 45 to 50 minutes, and we will follow it with a question and answer period. We're going to wait to answer any specific questions until that time to allow us to move through the material efficiently. And this webinar is being recorded, and we will load it onto the Penn TAP website shortly thereafter for you to go back and review. So before we begin, let's take a look at that trivia question. So how much energy did the industrial sector consume in the US in 2019? For those of you thinking that it was 32%, you are correct. Industrial sector is the largest consumer of the 4 sectors for energy in the US. Transportation was a close second at 28%, residential at 21%, and commercial being the lowest at 18%. So let's get started. During today's webinar, I'm going to provide you with several energy efficiency project ideas that once implemented will help you to reduce your operating costs, and that will allow you to offset any financial losses you may have incurred during this unprecedented time. I'm going to discuss energy efficiency projects that involve your lighting, compressed air, HVAC system, boilers, and your building envelope. Throughout the presentation, I'm going to cover no-cost, low-cost options, as well as more expensive projects, but we are going to discuss a few funding opportunities available to you that would offset projects that have a cost associated. I'm then going to conclude with a short overview of Penn TAP and the services that we offer. So let's begin with lighting. Lighting projects are a great way to increase efficiency and cut energy costs at your facility. Today, we are going to discuss 3 lighting project ideas. The first is daylight harvesting and delamping. The second will be occupancy sensors. And the third will be an LED upgrade from your current lighting. So let's start with daylight harvesting and delamping. Both of these are the simplest and fastest ways to decrease your lighting costs. Daylight harvesting is exactly what it sounds like. It is the practice of using the available daylight in your building whenever possible. Take a moment to think about your building. Think of those areas where you have a lot of windows. And are you using the lights in those areas? Are the lights even necessary? If the answer is no, just shut them off and use the daylight. Or let's think about those areas where there is little to no daylight. Is the amount of lighting necessary for the space? When you walk into that room, do you find it blinding and too bright? Could you perhaps turn a few fixtures off due to the social distancing requirements in place at the moment? In these areas, you may want to delamp. Delamping involves removing unnecessary fixtures or bulbs within a fixture and also goes hand in hand with daylight harvesting. This project is not labor intensive and it is so simple to complete. You are simply going to tour your building to identify areas where the daylight is present or the lighting is too bright to determine if you can turn off a fixture or remove some of the bulbs. And remember, lighting in stairwells and hallways is very, very important for safety reasons. So delamp with caution in these areas. If you look at the pictures on the slide, the one to the left shows a facility that's using daylighting in the form of skylights. And the one on the right is a perfect example of a delamped lighting fixture. The fluorescent is only included in the left side and the one on the right side is no longer being used. So there are several benefits to daylight harvesting and delamping. The payback period is immediate. The savings literally begins once the fixture or bulb is not in use. This is not a labor-intensive project, and it can be completed quickly. And studies have shown that increasing the natural light in a space will improve your productivity, your employees' mood, and their energy. And believe it or not, you are going to save on cooling costs in the summer because traditional lighting produces heat. While touring your facility to determine where you can delamp, you may also want to note areas where the lights are often left on when no one is in the room. Areas such as these are the perfect places to install occupancy sensors. Occupancy sensors will automatically turn the lights on when someone enters the room and turn them off as they exit. And they are most often installed in areas such as your restrooms, your break rooms, storage areas, warehouses, or conference rooms. Once installed, they have been shown to decrease the lighting costs of a space by as much as 90%. Now we're going to discuss upgrading the lighting in your facility to LED bulbs, which can cut your energy bills by as much as 30%. In addition to this, your maintenance and equipment costs will also decrease because LED bulbs can last up to 50,000 hours. And I want to put this in perspective for you. That means that a bulb that is on 24 hours a day 365 days a year may last you as long as 5.5 years. That is amazing. And an LED upgrade will also decrease your cooling costs since they produce far less heat than traditional bulbs do. And they do not lose their quality of light over time, unlike other lights which begin to deteriorate as soon after being installed. Notice the difference in lighting between the picture on the left when compared to the LEDs installed in the same area on the right. The lighting is crisp, it is clean, and it's going to remain that way for the life of the bulb. You can upgrade your lighting as a single and complete project or as the bulbs fail. But remember, it will take you much longer to see the savings, up to 5 years longer when you upgrade as the lights blow out. There are grants and rebates available to small manufacturers to help offset the costs of an LED upgrade, and we're going to discuss those later in this presentation. But I want to warn you, in most cases, you must upgrade as a single project to qualify. And by that, I mean, an area such as shown here, maybe you want to just do that huge production area because that's where all your lights are. It doesn't necessarily need to be every light in your building. It just means that upgrading one bulb at a time as it blows will not qualify you for those rebates or grants. So Penn TAP recently assisted a client with a lighting upgrade at their plant. While on site, we completed a walkthrough energy assessment where we not only looked at their lighting, but we also looked at their compressed air system and their refrigeration system. We provided the client with a full assessment report that included an analysis of their current systems and the savings based on our recommendations. This plant operates 24 hours per day, 7 days a week. The facility was being illuminated by T8 and T5 fluorescents. Upgrading these bulbs to LEDs saved the client $7,856 annually in electric costs. The client was also able to use Act 129 rebates from their utility companies to lower the cost of the project by $3,743. And don't worry, we'll discuss those shortly. And here's the kicker. The simple payback period was less than 6 months for this project. In addition, because LED bulbs generate less heat, this client also reduced cooling costs in their chilled storage areas by $531 annually. Now we're going to discuss compressed air. And compressed air is often one of the most expensive energy-related costs at a facility. Air compressors typically have an overall efficiency of just 10 to 15%, but do not worry. There are several things that can be done to increase the efficiency of your air compressor system. The first thing to do, and I cannot stress this enough, is to stop inappropriately using the compressed air at your site. Any use is considered inappropriate if it can be done more efficiently or effectively using another method. For example, are your employees using the compressed air to clean their workspace instead of a broom? Or is the compressed air running to equipment that is not being used? The table I've provided here shows several inappropriate uses of compressed air with suggested alternative methods to performing the same task. So take steps to eliminate any appropriate uses immediately. You can do this simply by walking through your plant and observing and identifying all compressed air uses. Be sure to check idle or abandoned equipment and note if the air supply is shut off when not in use. For example, perhaps you are no longer running a production line due to the impacts of the coronavirus. You may be able to turn the compressed air off for this line until it's back in use. Also, observe your employees to see how they are using your compressed air. You may also want to consult with a compressed air system specialist to see if other equipment, such as blowers or mechanical or hydraulic devices, would be more cost-effective for applications you're currently using compressed air for. Some other tips involve reducing the operating pressure of your compressed air without impacting your production. One way to do this is to reduce your pressure incrementally each week and then let it run for a few days to be sure it is meeting your demand. Or you may be able to reduce your pressure to match the required pressure of your machinery. I want you to remember, it only takes a reduction in pressure of 2 psi to increase the overall efficiency of your system by 1%. You can also use outside air as intake air to reduce the compressor's workload. This is based on the theory that, in general, the outside air tends to be cooler than the inside air in your compressor room. So in Pennsylvania, the average ambient temperature within a compressor room is approximately 70 degrees Fahrenheit, while the average annual outside temperature is around 50 degrees. The colder outside air is denser and it requires much less energy to compress, which increases the efficiency of the compressor. Capturing the outside air can be as simple as attaching one end of metal duct piping to an intake port and route the other end through the wall or ceiling. And it's important to remember, I know today here where I'm sitting, it's about 75 degrees outside right now. Using that outside air can still increase the compressor efficiency, since the outside air is still cooler on a day like today than the air in your compressor room, which can be as high as 120 degrees in the summer. Regular maintenance is also key to running that compressor efficiently, and you're going to hear me talk about maintenance several times throughout this webinar. Activities such as checking the filters and condensate traps regularly, or changing the oil as specified in the owner's manual, will increase the efficiency of your system. Also, you should consider using synthetic oil. It lasts longer and will save you on maintenance costs. So as part of your maintenance program, you should also check for leaks in your compressed air lines. These can be one of the largest sources of wasted energy at your facility. Leaks will cause your compressor to run more than is necessary and will waste up to 30% of its capacity. The table shown here provides you with the annual cost of one very small to one large leak at a facility using a 50 horsepower compressor. I want to stress to you that the costs provided here are the result of one leak of each size, with one large leak costing over $1,700 annually. Leaks will often occur in areas where the compressed air lines are connected to other lines or equipment, or in areas where there is a lot of movement or vibration. Examples would include the elbow of hard piping, the hose connecting to the hard piping, and the quick connects from the hose to the equipment. And believe it or not, compressed air is also lost where equipment is no longer used, but the air is still being fed to it. This is especially important consideration during COVID, where you may not be running at full capacity yet. So how do we detect leaks? This can be done as simply as running your hands along the lines and the equipment to feel for air, or you can purchase a device called an ultrasonic leak detector. They generally range in cost between $300 and $1,200. A leak detector will allow you to quickly find leaks in hard to reach areas or noisy environments. So think of some of those compressed air lines. I've been in facilities where they run along the ceiling. There is no way you're going to be able to feel for a leak with your hand, but that leak detector will let you know where one's present. And remember, Penn TAP provides no-cost compressed air audits for small manufacturers, so feel free to contact us. Once the leaks have been identified, they should be repaired as soon as possible. Now, most leak repairs will cost less than $50, and most are gonna range about be in the $20 range. You should repair the largest leaks first, since they represent the greatest loss of air in your facility, and they cost you the most money. And remember to continually inspect compressed air lines as part of your preventative maintenance plan. This will allow you to identify leaks while they are still small. Now we're going to look at a case study where we advise the client on fixing those compressed air leaks. We recently visited a food processing plant that was located in central Pennsylvania. They use compressed air to power their production lines. The compressed air is on at this site 18 hours a day, 6 days per week. While on site, we identified 18 leaks within the system. That was costing them $5,505 total. 11 of those leaks were classified as small. That was costing them $1,208. Now I want you to notice that the 2 large leaks cost this plant almost 3 times as much as the 11 small ones. If this plant had been checking for leaks on a regular basis, They most likely would have been identified and repaired while they were small. Overall, this plant is expected to save $5,505 annually now that these leaks have been repaired. There are rebates that will help you to lower the cost of the leaks, and we're again going to discuss those shortly. Next, we're going to talk about your boilers, and there are several ways to increase your boiler's efficiency, which will decrease your fuel consumption and costs. Once again, the key to boiler efficiency is proper maintenance. Have the boiler serviced and tuned up on an annual basis. Tuning up that boiler can increase the combustion efficiency and decrease your fuel bills by as much as 5%. Clean the tubes regularly and be sure to check for broken baffles. The tubes in the boiler pictured here became clogged with mineral deposits and caused some of those tubes to break. This may have been avoided with proper maintenance. Consider installing a stack thermometer and monitor the temperature on that stack thermometer daily. If you begin to see the temperatures rising, this is a good indication that your boiler may need to be cleaned or even serviced. Check your flue gas. This can be done by a consultant, a supplier, or yourself with a flue gas analyzer. And Penn TAP is available to conduct a no-cost flue gas analysis for small manufacturers. Checking the flue gas is a simple process. While the boiler is running, insert the probe of the flue gas analyzer into the exhaust stack. Be sure the probe is placed into the middle of the stack and hold it steady until the oxygen and temperature readings stabilize. The flue gas should be checked every 6 months to determine if a tune-up is necessary and to ensure that your boiler is operating at an efficiency of at least 80%. The photos on the right depict the results of a flue gas analysis. As you can see, the analysis will provide you with a wealth of information. This includes your air to fuel ratio, the stack temperature, and the current efficiency of the boiler. Another thing you can do is to reduce the steam pressure. Boilers operate more efficiently at lower pressure. A drop in pressure of 40 psi will increase efficiency by 1%. This can be done in the same manner as reducing the pressure in your compressed air system. Begin by lowering the pressure in increments of 5 psi and allow the boiler to operate for several days each time it is lowered. This will allow you to see if the system is still meeting your operating needs. Consider installing an economizer to reduce your fuel consumption. Economizers recover heat from the flue gas to preheat the water before it enters the boiler. Without an economizer, this heat is lost. Grants are available to help with the cost of purchasing an economizer, and Penn TAP is also available to assess your boiler to see if this is the right option for you. Now let's think about your condensate tank and your pipes. Are they insulated? If not, you are wasting fuel and throwing away money. The picture on the left is of an infrared image of an uninsulated pipe at a plant we had visited. The image clearly shows heat being lost from that pipe. And I'd like to note that the center of that pipe is around 229 degrees Fahrenheit. This is not only a source of heat loss and wasted money, but this is a safety hazard to your employees. They will most certainly get burnt should they come in contact with that pipe. There are several types of insulation available, but Penn TAP recommends fiberglass insulation with a jacket, like that shown on the right. It is relatively inexpensive and is easily installed. The jacket will prevent moisture from reaching the insulation in the event of a water leak, and this type of insulation is easily removed for periodic inspections or maintenance. We recently conducted an energy audit at a plant located in southeastern Pennsylvania. The infrared image on the previous slide was taken at that site where approximately 221 feet of pipe were not insulated. That meant that 793 million British thermal units, or MMBTUs, of heat was lost through the bare pipes each year. Once the pipes were insulated, this client saved $3,795 on fuel annually and reduced the heat loss to 114 MMBTUs. And I'd like to note the simple payback for this project once complete was just over 1 month. Now we're going to discuss your HVAC system. There are several ways to decrease costs associated with your HVAC, and most of which will not cost you a lot of money to implement. The first thing we will discuss, of course, is preventative maintenance. As with your boilers, annual tune-ups are key to running an efficient HVAC system. Replace the filters every 6 months. Be sure your heating and cooling ducts are properly sealed. And keep units free from debris and periodically check for leaking oil or refrigerants. Any leak such as that is a definite sign that your unit needs to be serviced. It can also be a safety hazard for your employees as well. So the unit pictured on the left seized up as a result of faulty controls. This may have been avoided if proper maintenance had been conducted. The photo on the right depicts a maintenance job that was not quite completed. And by that, I mean the panel isn't put back on. I know the doors are a real pain to undo and reinstall, but making sure the panels are on will prevent debris and even small animals from getting into that unit. That will keep your unit running efficiently. The next consideration is installing programmable thermostats throughout your facility. You can save as much as 10% a year on heating and cooling costs by simply turning your thermostat back during unoccupied times. If you do not have programmable thermostats, get them. They will save you money. Do you already have programmable thermostats? If you do, take a walk through your office area. If you see people using space heaters or personal fans, you might want to check where that thermostat is placed. Is it on the wall where the sun is shining on it, providing a false reading? Or is it below an air vent so that the area never gets quite warm enough? And by the way, even if you do not have them, you should still check, even if you do have them, you should still check for personal space heater and fans as they use energy. Ask the employees why they are using them. Sometimes it's as simple as switching spaces for the employee that's continually hot with the employee that's continually cold. You may also want to consider replacing old or oversized units with Energy Star units. Energy Star units use 6% less energy than a standard unit does, and you will save money once you are using an appropriately sized unit. There are grants and rebates available to help offset the cost of such purchase, and we will discuss those shortly. Last year, Penn TAP completed an energy audit at a small manufacturer in Latrobe, Pennsylvania. We looked at their compressed air system and HVAC units. The facility was heated and cooled by electric units that were over 35 years old. The air conditioning units were also oversized for their needs. Penn TAP recommended replacing the AC units with 2 that were appropriately sized for the facility and replacing the electric furnaces with natural gas units that were 96% efficient. We also assisted the client with a small business advantage grant to offset the costs of the project. In total, the client is expected to save $12,291 annually now that the project is complete, with a simple payback period of just over 1 year. Now we're going to discuss your building envelope. And the building envelope is essentially the shell of your building. It is the walls, the roof, and floor, and it includes the windows and doors. There are a myriad of opportunities that exist to improve your building envelope. And today we only have time to discuss a couple of those. The first thing you should do is inspect the seals around all windows and doors in your building. This is one of the cheapest and easiest fixes to prevent heat loss. And I want you to remember that losing heat in the winter means you are also allowing heat to enter the building in the summer when your AC is on. You can identify leaks by simply running your hand along a door or a window. Anywhere you can feel air is an area where a seal or weather stripping should be replaced, or the window needs to be recaulked. Likewise, take a look at your exterior doors and garage doors. Can you see daylight shining through them? If you can, it's in time to replace the weather stripping or seal. So let's consider garage doors. Garage doors are a very common source of heat loss. The seals tend to become worn and broken due to all the moving parts in that door. Those worn out seals will allow a significant amount of cold air into the facility in the winter or heat into the facility in the summer because they are present around the entire perimeter of that door. As shown in the table, one leaking garage door can cost you as much as $223 a year in heating costs alone. Now, can you imagine how quickly those costs add up if you have multiple doors in your facility? Exterior doors are another source of heat loss. The picture on the right is of a door with a 2-inch gap along the bottom and side where the cold air is coming into the facility. This 2-inch gap is the equivalent of a 72 square inch hole, almost the size of a piece of paper in the side of your building. Now I know each and every one of you would repair a hole in the building immediately, and you should do the same with the weather stripping on that door. And don't forget to check your windows. Recaulk them as necessary and consider hanging draft-proof curtains. They can act just like insulation and prevent heat from escaping. You should also take a walk around the outside of your building and look for cracks or holes in the exterior walls, such as those shown here. These not only represent a source of heat loss, but can also allow moisture to enter your building. So now you're not only wasting energy and losing money, you have the potential for a mold problem as well. Seal any air gaps or cracks and repair improperly sealed holes or missing seals and caulking. As I have mentioned throughout the presentation, there are grants and funding available to help you offset the costs of an energy efficiency project. Today, we will briefly discuss 3 of those programs. We're going to talk about the Act 129 Utility Rebates, the Small Business Advantage Grant, and the Rural Energy for America Program or REAP grant. Detailed information about each of these programs can be found on our website under the Energy and Environment tab. In addition, Denise Bechtel, Penn TAP's team lead for Energy and Environment, will be hosting a webinar with Ed Boito, the Small Business Ombudsman from the Pennsylvania Department of Environmental Protection. This webinar will be dedicated solely to funding for energy efficiency upgrades, and it will occur on Thursday, July 16th at noon. So first, we're going to discuss the Act 129 Utility Rebates. PA Act 129 requires that Pennsylvania's major electric providers reduce energy consumption and demand within their respective territory. To do so, these companies offer rebates to incentivize energy efficiency projects or the purchase of energy efficiency equipment. The Act 129 programs are funded through a surcharge in your electric bill, and the current programs are in Phase 3, which runs through May 31st, 2021. Now, there are slight variations to each company's rebate program, but in general, you can use the rebates to offset the cost of new equipment for lighting upgrades, HVAC equipment, motors, and a variety of other items. The final rebate amount is usually determined based on the project, but typically ranges from 2.5 cents to 5 cents per kilowatt hour saved. I want to stress that in most instances, project pre-approval is required. And by that, I mean you probably should call your utility company and make sure you're purchasing the correct equipment, or they will cover the cost of your project to be sure to get the most out of those rebates. And I also want to stress that this is the major utility companies throughout the state. And by that I mean PECO, First Energy, PP&L, Duquesne Light, to name a few. If you are in a co-op, you may want to contact them to see if they offer a similar program. Next, we're going to discuss the Small Business Advantage Grant, which is awarded by the Pennsylvania Department of Environmental Protection. This grant usually opens in July with $1 million to be awarded, and it continues until the funds have run out. Grants are awarded on a first-come, first-served basis, so it is very important to act quickly once it reopens to ensure funds are available. The grant will cover 50% of the project costs, up to $7,000. To be eligible, your company must have fewer than 100 employees, and the project must decrease your energy consumption by at least 25% and save you $500 annually. In some instances, you are also required to buy Energy Star equipment. If you are interested in applying, please contact the DEP's Small Business Ombudsman Office. The contact information is provided there, and Penn TAP is available to assist you with the grant application. So let's look at a case study where one of our companies that we recently helped use both the rebates and the SBAG to offset the project costs. This was a 60-employee manufacturing company located in Western PA, where we recently did an energy audit. We advised the client to upgrade their lighting to LEDs and help them with the Small Business Advantage Grant application. The company was awarded a grant of $4,846 and qualified for more than $4,400 in utility rebates. The project cost was just over $19,000 with an anticipated annual savings of over $11,293 a year. The simple payback for their out-of-project costs was less than 1 year due to the grant funding, the utility rebates, and the annual cost savings from the lighting upgrade. Now we're going to talk about the Rural Energy for America Grant, or REAP grant, which is awarded by the United States Department of Agriculture. Grant applications can be submitted year-round, but are awarded on a semi-annual basis. The grant will cover 25% of the project costs up to $250,000. You must be a small business located outside of a town or city with a population of more than 50,000 people. Believe it or not, that is a lot of area in Pennsylvania. So REAP is a highly competitive grant program where the application is scored based on 7 different criteria. Criteria includes the size of your business, the simple payback period, and the energy saved, generated, or replaced, just to name a few. Those receiving the highest scores are awarded the grant. Grant applications are reviewed in April and October. And like the Small Business Advantage Grant, we are here to assist you with that grant application. We recently helped a company in Greenville to obtain grant funding to replace an oxidizer that would reduce pollution and energy at their site. Penn TAP determined that the REAP grant would be the best option for funding based on the size and timing of the project. We completed an energy audit at the site and assisted the client with the analysis and calculations. Penn TAP provided the client with a summary report to be included in their grant application. This company was awarded $55,538 REAP grant and was able to save $43,053 in energy costs with the new equipment. And again, more detailed information about REAP, the Small Business Advantage Grant, and the Act 129 rebates is available on our website under the Energy and Environment tab. So now that we have discussed several project ideas and funding, I would like to take a moment to tell you a little bit about Penn TAP. We are a statewide technical assistance organization that supports Pennsylvania businesses and anchor institutions, including manufacturers, municipalities, educational institutions, entrepreneurs, and economic development agencies. We began over 50 years ago as one of the first technical assistance programs in the country, and you can find us at pentap.psu.edu. Penn TAP has a diverse staff with backgrounds ranging from chemical engineering and electrical engineering to environmental science. Our staff includes certified energy managers, registered environmental managers, certified energy auditors, and a Six Sigma Green Belt. We also have a certified practitioner in energy management systems on staff. He is one of only 6 certified in the state of Pennsylvania. We work closely with our clients to understand their needs and make appropriate matches to resources within the university and across the state through our statewide resource partner. Our services include 2 pillars. We have the energy and environment side and the innovation side. The technical advisors for the energy environment team perform pollution prevention and energy efficiency assessments, also known as P2E2 assessments, where we help you to decrease pollution and increase energy efficiency at your site. The E3 assessments build on the E2 assessment by incorporating lean manufacturing into the process. We offer energy management systems, which will provide your company with the framework to integrate energy efficiency into your existing management systems. And building retuning offers those involved in building operations a low-cost approach to energy efficiency. We offer opportunities to Penn State students in the College of Engineering to gain real-world experience by having them assist us with energy audits. And again, we go beyond energy as we also work closely with our clients to understand their needs and then match them to additional resources within our university and across the state. The innovation side of Penn TAP provides technical and entrepreneurial assistance directly to companies. They connect them with the faculty, students, laboratories, and infrastructure of Penn State through the EDA University Center and Engage, as well as to our resource partners throughout the state. Innovation also brings companies to Penn State's Learning Factory, and I love talking about the Learning Factory. Any company sponsoring a project at the Learning Factory is assigned a team of up to 5 Penn State students from various engineering backgrounds to work on your project. Previous sponsors have included GM, Boeing, Shell, and FedEx, just to name a few. And past Learning Factory projects have included everything from developing lightweight surgical lead vests to 3D printing for replacing obsolete parts. Innovation also helps student entrepreneurs with the first steps in pitching their business ideas and procuring funding. In 2019, Penn TAP helped 125 companies in 42 counties throughout Pennsylvania to save a total of $4.5 million. 38 projects were completed at the Learning Factory due to the connections made by Penn TAP, and $30,000 in grants was provided to student startups. Before we conclude, I would like to tell you about our upcoming webinars. We already discussed the first, but I'll tell you again, on July 16th, Penn TAP will be hosting the Funding for Energy Efficiency Upgrades webinar. It is from 12 to 1. Join us as we discuss several funding opportunities for energy efficient equipment upgrades for small to mid-sized companies throughout Pennsylvania. Join us again on October 2nd for the Manufacturing PA Innovation Program webinar, also from 12 to 1, where we will provide you with more details about the PA manufacturing program, the application, and how to make connections with Pennsylvania universities and colleges. And be sure to visit the Penn TAP website to stay connected and be informed of upcoming Penn TAP news, webinars, and workshops. And speaking of the Penn TAP website, be sure to check out our newly released energy toolkits. These toolkits are free to use and are filled with resources to help you estimate the potential savings from energy efficiency projects in your home or at your facility. The toolkit is divided into 4 sectors: commercial, manufacturing, residential, and schools or municipalities. And it provides the users with energy cost calculators, fact sheets, and supplemental resources. And remember, once you're done there, contact Penn TAP for a professional energy audit at your manufacturing facility to narrow down where to begin your next project. At this time, I would like to thank you for taking the time out of your busy schedule to join me and to learn more about using energy efficiency to offset financial losses. If you have any questions, please feel free to ask, or you can send me an email directly at jsm148@psu.edu. So at this time, we'll begin taking questions. I'll just give it a couple more minutes. Here we have one. So one of the questions we have are the assessments free or do they cost money? Our assessments are free for small manufacturers within the state of Pennsylvania and schools and municipalities. If you tend to be a much larger company, not considered a small business, then we can offer you an assessment, but usually there's a small fee associated. Are there any other questions? That's a good question. How do service providers get tied in to provide the energy services? What I would recommend is contacting Penn TAP. You can contact me and I will put you in touch with my team lead and my director, the team lead being Denise Bechtel and my director being Tana Pugh, and we can discuss that a little bit further. My email address again is jsm148@psu.edu. Oh, thank you. Are there any more questions? Don't be shy. Yes, that is a good point. There is a reminder, rebated projects, if you're using the utility rebates, your project must be installed and completed before May 31st, 2021. Just a couple more minutes. Well, if there's no other questions at this time, I'm going to thank you again for joining me on this beautiful summer day over your lunch break. If you have any questions, please feel free to call me. Again, Do we have one more? Again, you can reach me by email, jsm148@psu.edu, or you can call my office, 814-865-4542. I hope you all have a great holiday weekend and stay healthy. Thank you.